Welcome to CyrQ Energy's Soda Lake Geothermal Power Plant, a 100% renewable green solution for power generation, available day and night. This plant will supply the University of Utah with nearly 50% of its electricity with the goal of carbon neutrality by 2050. The Soda Lake plant site and well field is situated in the 40-mile desert along the historic California Immigrant Trail. Immigrants pass the area on their way to the future site of Reno, Nevada, and the California Gold Rush in the mid-1800s. Geothermal hot water was discovered by Chevron and Unocal when the oil companies were drilling for energy sources in the 1970s. The first power plant was originally developed in 1987 and started on Christmas Day of the same year. That original plant was one of the first geothermal power plants in Nevada and has continually operated for more than 30 years. The site for the Soda Lake 3 geothermal plant, which will deliver electricity to the university, is named for the nearby lake of the same name, used as a soda ash mill in the 1800s. Let's see how the process works. Hot water from the earth is pumped from production wells using pumps set deep in the earth. The hot water, called geothermal brine, flows through the geothermal piping system to the power plant, where the first stop is the level 1 vaporizer. The hot water flows through the tubes of the vaporizer while transferring the heat to a working fluid, which boils at a lower temperature than the geothermal brine. Because there are two fluids, the geothermal brine and the working fluid, this process is called binary geothermal. The working fluid evaporates and is superheated in the vaporizers, which changes its state from liquid to high-pressure vapor. The working fluid vapor is directed to the turbine, where it expands, dropping in pressure and temperature and producing rotational shaft power. The turbine rotates the generator, which generates electricity. After rotating the turbine, the working fluid, now a low-pressure vapor, flows to the air-cooled condensers through a recuperator, where it is condensed back into a liquid state. The geothermal brine is then re-injected back into the ground through the injection wells. This completes a 100% closed-loop use of the geothermal brine, which is only used to transport heat from the earth to be converted to electrical energy. The geothermal power used by the University of Utah is one of the most consistent and reliable sources of green, renewable energy.